Thank you. It is an absolute pleasure to be here. This is my first time to Turkey, and it is absolutely stunning. To start things off, I have a quick video to show you.
Ladies and gentlemen, Easton Lachappelle.
Thank you. I'm here because I want to do something big. I ask myself now, how do I do that?
I remember him when he was in 7th grade. He walked into class and he hadn't even sat down yet. He said, "I am so excited to do this lab. I've been thinking about it all morning. I just can't wait." And I was like, is he kidding? When he was in 9th grade, Easton stopped in to say, "I've got this great idea."
It was exceptional to see that he was producing this in his bedroom.
And I can shake hands with myself now.
It's awe-inspiring, and each year it just gets more and more amazing.
And, when I think he just turned 19 years old, in November, it's hard for me to fathom what's next.
Recently, I graduated high school and started a company called Unlimited Tomorrow, where a few of my friends and I were trying to change the world.
We're in a garage in Cortez, Colorado, which is a very small town, hours away from the nearest interstate.
We are making robotic limbs to help people do things that they normally wouldn't be able to do.
My name is Rich Stewart. I'm 51 years old, and I was involved in an accident. High-pressure oxygen bottle exploded and lost my right arm immediately. I was fit with a prosthesis, hook, as everyone calls it. Now it's part of my identity.
Hey, pleasure to meet you. So I have a lot of cool stuff to show you, yeah. This hand is actually operated using your thoughts, using your brain waves. So that reads right about 12 different channels of your brain. I would love to have you try this and see if we can get it moving. Try and only focus on one thing.
All right. It's a big deal for me. It could mean confidence, it could mean more ability. I could see this being something that could change my life.
I was a kid when I was little that I took everything apart. I always had a curiosity for how things worked and really how they work so well. I took apart everything I got, from toasters to microwaves to game consoles. I always had a curiosity for really what was happening inside. Specifically, there was these little black chips, these electronic chips that really power the world that we live in today. And you know something is happening inside of it, but you can't see it. And I was always fascinated. I was always trying to find an opportunity in a way to actually fathom what was happening underneath that surface, to actually fully understand this and maybe apply it to other different applications or products. When I was trying to always find a project, something I could build that would really give me kind of an excuse to really dive into these electronics and start learning all the mechanics and software behind what actually goes into developing a product. When I was 14, I came up with my first kind of practical idea, which was to create a robotic hand controlled by a wireless control glove. Now, being 14, that was kind of far-fetched. It was essentially a robotic hand that was controlled by a glove. You put this glove on, and when you move your hand, the robotic hand will actually copy your movements. For me, I thought that was just something that was cool. Being 14, I could imagine putting on this glove and moving your hand and seeing something actually copy and mimic your motions. For me, it was motivating just to see it work, to see something I actually made with my hands, see it actually fully work, and so I started diving into this project. Before this, I had no prior knowledge to electronics, mechanics, the software, and for me, it was kind of hard to dive into this project. The first thing I did was I went to online, I typed in YouTube, and I wanted to see if there was maybe a tutorial on how to make a robotic hand or how to actually make this whole project. Now, I didn't find that. So for me, that was kind of discouraging, but also encouraging at the same time. Somebody hasn't made this before, and this was something that I had an idea that maybe someone has had before, but maybe wasn't able to make it, or maybe they haven't had it before. And so I was really motivated to try and make this a reality. The internet was a tremendous tool. It's a tremendous resource. Literally, all of humankind's history is at your fingertips. And so I turned to the internet. The number one thing that it provided for me was communication. I could talk to people all around the world, ask the specific questions that I needed answers for to fully understand, start actually learning these basic building blocks of the system to start making this full project. So I turned to the internet. I found a few sites that really promoted fun and learning. Those sites include SparkFun, Adafruit, Hackaday, to name a few. And what I found to be efficient was to actually break this project down to smaller projects. So the first thing I would do was actually essentially learn how to create a circuit for the sensors. There's a glove that have the sensors on it. This is actually the first glove that I made. And so you could see that these sensors have wires going into an electronic board. I first learned how to actually make that circuit. From there, I wrote simple software to just read the raw output of that sensor. I slowly started elaborating on that, actually hooking up motors. How do you actually move motors? How do you move that motor with a sensor? And then slowly multiply that by 5, and you have a full control glove that can control each individual finger of a robotic hand. So this was kind of the start of this. This was something that, again, I was right about 14. I really didn't have materials and everything laying around to make a robotic hand, so I had to be creative with how I started. The first thing I did was actually make a robotic hand, actually made out of electrical tubing for the fingers, a fishing line as the tendons, little servo motors from RC airplanes as the actual motors, and Legos as plastic supports. For me, that's what I had laying around. Now, for me, this was truly a start. Once I finally saw this working, it was so exciting to actually see something I created, my raw idea, turned to reality. And one of the main factors of how I actually learned how to create something like this was that there's this whole community called the open source community. Open source means that people actually essentially make the project open. They release the software, they create a tutorial behind it, and actually encourage people to make this and to replicate it more and more, which is really valuable for learning. You actually understand the full design kind of process that goes into something like that. And so with that, you can take bits and pieces. And so, and actually start applying it to maybe your own project or start building your knowledge more and more. A big part of everything I do is really sharing what you've created. For me, that's how I learned. I learned by people sharing and being able to communicate with people all around the world. And so I actually made a YouTube video and tutorials that actually walk people through how to make this robotic hand and actually encourage people to replicate it and to change it, make it better and better. And so I think that's kind of an interesting aspect of today's world, is that we have so many tools and resources now that we can almost create kind of a domino effect, is that one person creates something and everybody else can follow and maybe improve on it, maybe have a different mindset going into it that maybe I didn't think of. And so for me, that's extremely valuable. Now, once I saw this robotic hand working, I knew that this was just the start. This was the proof of concept. This whole system actually worked. I was able to turn an idea into reality. And so I saw so many different ways to actually make this better, improve on it. I can make it more human-like. I could have actual joints within each finger. I could have an opposable thumb, and maybe even start building the full robotic arm. And so at this time, there was this amazing technology called 3D printing coming out. How many of you have heard about 3D printing? A vast majority of you, which is really surprising. Now, 3D printing is this amazing enabling technology. It allows someone to create something extremely customized for a fraction of the cost, which is really key for a lot of these problems within today's world. 3D printing at the core of it is actually a really simple technology. You have 3 motors, which are essentially 3 axes, X, Y, and Z, that are able to manipulate a point within 3D space. That point is an extruder that heats up to right about 230 degrees Celsius, where it actually starts to liquefy plastic. Now, you actually design something in the computer. So what I did was actually design this full robotic hand in a program called CAD, Computer-Aided Design, where I could actually draw in 3D. And I needed some way to actually turn that into a physical object, which 3D printing was obviously the answer. But 3D printing, when I first got started within this, was just starting to hit the consumer market. And so it wasn't everywhere. And so I needed to be kind of creative with how I went about this. I didn't have access to a 3D printer. I actually sent my files out to a company in Colorado where I'm from, and I was getting quotes upwards of $500 just to create this robotic hand. Now, for me, that was almost where I threw in the towel. I almost quit because I didn't have $500 to put into something like this. I didn't even know if that design would mechanically work. And so I gave it one last push to see maybe if there's someone else that had a 3D printer that I know. And that actually on social media was a tremendous tool for that. I actually had a friend that was working at MakerBot Industries in New York, was one of the first few employees for the first consumer 3D printing company, and he was able to throw it on the printer one night, and I had to pay for shipping. So $500 to right about $15 is definitely a little bit more doable for a 15-year-old. And so once I had this, I saw so many ways I could make this exactly what I had in my head. I could start building on the form and all the way up to the full arm, all the way up to the shoulder. Now, this was something that was a completely new territory for me again. I've never built a robotic arm. I've never had to program something this extensive or anything like that. So I kind of took it in pieces. I actually was using Science Fair as a platform to share my ideas. It gave me an excuse to make something cool every year, and it allowed me to communicate with engineers, people who have been within this industry for all this time. And for me, the number one most valuable thing for me is someone else's perspective. If they look at this project, maybe they can see something that I didn't see, maybe a way to improve on it, maybe something I did wrong. And so for me, getting someone else's feedback is really key. Science Fair was a tremendous platform for that. Now, I had this robotic hand, and I had a few more months until the Science Fair, so I wanted to challenge myself. I want to try and make the full robotic arm. Now, this in itself is a challenge. How do you even find motors that are strong enough to even hold itself up? Say with the shoulder, 2 pounds in the hand could be 20 pounds of torque for the shoulder motors. So it had to be extremely strong, even just to power itself. It also had to be accurate. I had to actually control it to be able to do human-like tasks. And so I started piecing together, kind of household objects again. For the elbow motor, I actually used a windshield wiper motor from the car. It had a perfect gearbox on it. It was cheap and reliable. They're everywhere. And then from there, I slowly started piecing up to the shoulder. Now, I needed some way to actually know where the arm is at within 3D space. I needed some kind of sensor. And so what I turned to was actually potentiometers, what's found in volume knobs or light dimmers. They're everywhere in today's world. They're practically pennies now. And so what I did was I took a standard DC motor, put that on the end of the shaft, and essentially turned that into a servo, which means that I can tell it an angle to go to, and it'll go there and hold. And so now when I actually program this to make certain human-like tasks, such as going up and shaking your hand, it's a lot easier to program. And that's, again, making a platform so people can actually take this and replicate it and recreate it was really key for something like this. So I entered this into the Science Fair, and with this project, it was really amazing. I grew up in a small town in Colorado called Mancos, Colorado, which has right about 1,200 people as a population, which I imagine is probably more people in this room than where I actually grew up, which is an interesting concept. But I knew that this was really something I wanted to do. I saw so many ways to make this better. So I entered this into the Science Fair, and at the State Science Fair, this moment happened. I met this small girl that actually had a prosthetic limb. I noticed this small girl, she was coming up, she was playing with a robotic hand, she really had a big interest into it. A lot of the kids, they would come up and kind of look at it, but she was really intrigued by it. And I started talking to her parents, and I realized that this girl actually had a prosthetic limb that was very simple. It was an open-close prosthetic, so it was almost like a claw. It had a single sensor sensor, and so it was open-close. Now, the thing was is that she was 7, so she needed about 2 or 3 prosthetic limbs in the future. But the main thing about this was the cost of that prosthetic. The cost was right about $80,000, which is a tremendous amount of money for anybody. And so this was truly the aha moment for me. I saw an opportunity that I was making in my bedroom for fun that I could potentially impact someone's life. Now, I know that she was not the only one out there, missing a limb. And so there was so many other people, so many problems that we could really solve with this new technology, 3D printing, electronics, a software that all combine into one to make a system. Now, I went back to the drawing board. That was the motivation I needed to really take this project to the next level. I found an application. This wasn't something I was creating for fun anymore. I was working towards a goal. When I started researching and actually talking to other amputees, I realized that there was a lot of other problems with the prosthetics. It was the functionality. What if this girl actually had individual finger motion, individual finger movement of her robotic hand or prosthetic? She could do really any tasks that she wanted to. She could tie her shoe. She could regain independence, which is really key for someone with a disability. The other problem was the control, how you actually control it. Now, if you increase functionality, that means that you have to control more movements, which is kind of a sticky situation because there's really no good control system out there. There's some muscle control systems which are limited to a few motions. Then once you get to, say if someone's missing a full arm, if you're trying to control 6 movements at once, muscles is really not practical at that point. There are some really advanced brain control prosthetics that actually require an invasive surgery to actually implant sensors within your spinal cord. That has a lot of risks associated with it and also a lot of cost, which is still kind of one of the main problems. Also the mounting, how the actual prosthetic attaches to the human. For that, throughout history, people have been essentially using the same technology. It's essentially a socket, kind of a cast that goes over your arm or your residual arm that straps to it. And there's some new technologies that are actually held on by suction or vacuum pressure that actually hold the whole prosthetic onto the person. But now when you actually exercise, or if you're outside, if you lose any kind of suction from sweating or being active, it can just fall off. And so that technology is starting to increase more and more, but it's still one of the main problems. Also the weight. The weight is a big problem because the robotic arm or prosthetic is actually dead weight, which means that it actually will feel different than your real arm versus the prosthetic, even if it is the same weight. And so a goal of mine was to definitely make this as light as possible. With 3D printing, I could solve all these problems. I could make custom joints, I could print custom gears, make everything as small as they needed to be to increase the functionality. By doing that, I could decrease the weight by really optimizing the placement and all the motors within that. And then with the control system, really focus on how you actually control everything accurately and do the arm and actually move the arm exactly how you want to. Now, that's kind of one half of the puzzle is building the full robotic arm. When I was 16, I actually got my first 3D printer from the Kickstarter project, which was so amazing. I had this 3D printer in my bedroom, and I was printing 24/7. I could design something, I could hit print. If it didn't work out, I could change it a little bit, hit print again until it is perfect, and then start printing multiple ones of these. So in no time, I had a full robotic arm that I could actually start controlling and actually playing around with. This was one of the first robotic arms I made. This was the first robotic hand I designed, and you can actually see the windshield wiper motor within the elbow. This is the newest, this is actually the last generation arm that we made, and this is the one that I went back to the drawing board and really started recreating around the prosthetic. And so this was pretty much the result. This is the full robotic arm that I made. You could see that it was human-like. You could see that it had human-like motion, a similar functionality to a human arm. But again, that was one half of the puzzle. The other half is how you actually control it. How do you actually merge man and machine in the best way possible? Now, we control our arms and hands with our brains. So that was my first initial thought was, what if we could use the brain? Stay away from some of these surgeries. Maybe if we could do it externally, that we could start going towards the right way. We could actually start controlling more and more movements based off this thought. Now, being right about 16, I had no idea how to even dive into actually reading brainwaves, or let alone actually controlling something with this. And so I turned to the internet. There was some commercial headsets that were out actually used for biometrics and biofeedback to actually that would interface with your phone. So you could actually, it was all Bluetooth, it was all wireless. And so I got one of these, and the first thing I did was actually hook it up to a computer. I hooked this up, and I sat in front of the computer for probably about 4 hours. I was trying to figure out if there was any waves I could control voluntarily. So I read a book, I tried to play with my emotions, see if there's anything I could actually control. And if I could control, that means I could maybe control an actual motion of the robotic hand. Now, the sensor, this technology is moving extremely fast, but it's not quite medical grade. An example of actually using this headset was actually just to open and close your hand. So say if I'm picking up a glass of water, the more I focus and harder I focus, the more the hand will actually close and grasp it. And so with that, based off kind of working around this technology that's out now, I started increasing the number of sensors. If we could increase the number of sensors on the actual headset, and maybe even add muscle sensors, because muscle sensors are definitely proven technology and works for a lot of other motions, then maybe we would have a really solid system to control a full robotic arm. And so with this, the headset reads right about 12 different frequencies of brainwaves. Reading the brain is actually simple. It's simpler than you think. It's actually kind of like a muscle. Your muscles are constantly giving off small electrical discharges. Your brain is also. And so if you have contacts on your brain or your head, you can actually amplify that to something electronics and software can actually read. Now within that, certain regions within your brain correspond to certain thoughts and movements like that. So there's a tremendous really way that we can actually use these brainwaves to control something that is advanced like a robotic arm. So I had this full robotic arm. We started playing around with the brainwave control. The brainwave sensor actually was able to read facial gestures, which was a really interesting aspect of controlling a robotic hand. And then also muscle sensors. So we combined those three things to create a seamless result to control 6+ movements of the robotic arm. Again, actually using waves that you could actually focus. It was a great example when Rich, the amputee who came to our facility, I actually never met him before this. This is the first time he actually came to our facility. This is the first time he actually saw this technology. And it was a really amazing moment to see him actually put on this headset and start controlling this hand. Now, it took him about 10 minutes to fully pick up on the movements. Within about 10 minutes, he could open and close the hand. He could actually change grip patterns to pick up certain objects and things like that. And so that's something that we didn't actually expect. That was something that we were working towards, but really didn't realize that it would work this well, this fast. It was really, really cool to see a stranger take this and pick it up so fast and actually be able to do functional tasks with it. Now, this was at the time where media really started to pick up. This was something I was still playing around with in science fair, and at this time starting to talk about what I was doing and kind of my journey up to this point. Starting in a small town with no prior knowledge, using resources that are really available to the world now, and starting to actually teach myself what I wanted to learn, which in the education system, for me, wasn't always encouraged. It was always, there's a lot of boundaries within the education system, but for me, I knew what I wanted to do. I saw so many goals that I wanted to complete and really work my way up to. And I knew that school, especially at high school, just couldn't get me there as fast as I wanted to be there. And so that's when I started turning to the internet, working my way up to actually get this base knowledge and then building something from that. Because of science fair, it allowed me to meet some incredible people and to really start kind of getting my name known out there. I was actually invited to the White House because of the science fair. I was invited to the 2013 White House Science Fair, where President Obama actually shook hands with one of the arms I made. This is the arm that was actually controlled using a brainwave sensor, and this was really an amazing moment. This was the moment that I realized that this was bigger than I thought. This was something that could really make an impact, not only to the small girl, but to people all around the world. And maybe this technology could be used for other applications. Maybe you don't need to replace a limb. Maybe you could use it for automation or certain tasks within dangerous environments, such as bomb defusal. There were so many applications I saw within this. Now, at this time, I gave a TED Talk in mid-2013 where I mentioned this young man I was going to school with. This young man actually became paralyzed in a severe car accident. And for me, I knew him pretty personally, and this was something that was kind of hard for me to wrap my brain around. This was a very active kid who loved skateboarding and being outside, and after this accident, he pretty much had to relearn life in a way. He was bound to a wheelchair. He was paralyzed from the waist down, and at that time, I was in the heart of technology. It was moving extremely fast, and I thought, maybe there's a technology that can help him regain walking or independence. And so I started researching, and I found out that there's these things called exoskeletons, which are external robotic devices to help someone who's paralyzed actually walk again. But it was kind of the same concept and some of the same issues as prosthetics. They were $100,000. They had limited functionality, right about 3 hours of battery life. And so I actually got a call because of this TED Talk from this man named Tony Robbins, who's a very well-known motivational speaker and businessman alike. He actually reached out to me and said that he actually saw this TED Talk, and specifically where I mentioned this young man I was going to school with who became paralyzed, and he's helped a lot of people psychologically, but together we can go a step further to help him physically. And so at that time, with Tony Robbins coming on board and two other amazing co-founders, Aaron Blue and Tim Schneider, we formed Unlimited Tomorrow. This was taking this idea and really turning this into a practical and business opportunity. Before, there was really no way to actually get this to the people who need it. But by having a company and a business structure behind it, now we can actually legally protect this if we needed to, or actually start working with regulations and actually start producing this and getting it to the people who really need it. Now, at this time, there was a few interesting things that went on with these robotic arms. I knew everybody that needed it, and how do you actually get this to everybody who needs it? How do you really target the world with this technology? And that was a difficult part of this. And so if we went through the conventional route, which would be essentially patenting this, going through regulations, or with in this case, in the US, FDA approval, which is a very expensive and time-consuming process, it then can turn into actually selling to the world and amputees, but you're actually working then through insurance, and then so it's kind of this convoluted game, which then a lot of people actually start increasing the price because insurance is involved, and then you kind of get back to the same problems where, again, you have limited functionality, the weight, and the cost. And so I knew I needed to get this to people who really needed it. So how do you go about this? And luckily, at this time, there was these new business models that were coming out. Again, going back to open source technology. I thought, what if I could make this open source? What if people could go online, actually download this robotic arm and print it or actually construct it themselves, and then maybe use it for themselves or actually give it to someone else? Now that's actually starting to become practical because you're leaving it to individuals that have the motivation and drive. And this technology is growing more and more. 3D printers are almost everywhere today, and they're becoming more and more affordable and cheaper and better and better materials, everything like that all around. And so this was a structure that made a whole lot of sense to actually get this to the people who really needed it. So we actually decided to make the newest arm open source. This was the full robotic arm that we made. This is the newest generation, so pretty much took all the past generations, combined it into one, and this is a truly amazing platform. It's completely 3D printed, fingertip all the way up to the shoulder. All the gears, internal components are all 3D printed. The only thing that's not 3D printed is a few nuts and bolts and some motors and electronics. We actually encourage people to replicate this and make it and change it to to use it for different applications, not only prosthetics, but again, maybe automation, low-cost automation. And the cool thing about this arm is that it's actually modular, meaning that all the joints can be interchanged. So you don't have to make something that looks human-like anymore. You can make something that has a giant 20-degree freedom arm for, again, low-cost automation or whatever application you can think of. Also, because it's modular, it makes it a lot more practical for prosthetics. Say if I'm missing below the elbow of my arm, I would just need to have the hand, the rotation joint, and the forearm. So I can construct what I need. I don't have to make the whole thing and alter it and start playing around with all that. Again, really designing it for the consumer and really looking at who the audience is and how this technology can really be used for something like this. This also has tremendous applications because it's open source within education. Imagine if we actually paired a curriculum with this that actually walked you through the construction and then actually, all the different fundamentals and building blocks that go into this, that then you actually start building a base knowledge that then you can apply to other applications. So this could be a tremendous learning tool as well. A really amazing thing about this robotic arm is that it costs us right about $400 of materials to produce, which is extremely practical in today's world. So we could go from $80,000 to $400 or a few $100s and really completely change people's lives. People's lives that they've had to go without a prosthetic or having to completely relearn life because of cost of medical devices and these devices that they need to regain independence. And so this was a really exciting time to make this. Now, with open source, it's interesting on how it actually works within hardware. A lot of open source technology is actually software, actually like Linux or Android, things like that. But when it comes to hardware, it's really interesting. So we actually promote this as a robotic kind of platform that people can then download and take and use for all sorts of different applications. We actually made all the files open source and able to download on our website, and we actually have tutorials that teach you how to construct each component and how to build it up. And so we're already starting to see people actually take this and create it and change it and adapt it and use it for all sorts of different applications, which was really the goal. So this was really exciting to see. Throughout this process, one of the biggest things about this is the control system. The brainwave side and the muscle sensors and creating these hybrids and really merging man and machine is a problem that is in not only prosthetics, but in multiple other industries. That's something that I started seeing more and more. I actually did an internship at Johnson Space Center at NASA in Houston, where I worked on the Robonaut project, which was a really fascinating project. And they had the robot built perfectly. It was this amazing, amazing robot that it could replicate human motion, and the goal of it was to essentially go EVA, to eliminate astronauts from actually leaving the space station to do spacewalks. You could send a robot out, eliminates a lot of that danger and risk associated with actually putting a human directly into space. And so this was a really fascinating project. Again, there's kind of two pieces to the puzzle, right? There was the robot, which they've been working on for years and years, and then the control system, which has been trying to work with the robot, and it's been advancing with the robot depending on the robot's capabilities. And so that's something that I saw that even with NASA they were struggling with as far as the control system, because there's so many motions. They have an incredible amount of degree of freedom. They have fingers that can separate, go apart, and incredible thumb motion, and even just to control that is a challenge in itself, and that's only just the hand. Now imagine the full torso, the head. So there's a tremendous amount of sensors that you actually have to read and then control. Now that wasn't the only application. Within bomb defusal, that was a great application for control. Kind of an example is that the controls are really lacking behind these robotic platforms. A lot of the functionality is actually decreased based on the controls. A great example of this is heavy machinery, like a backhoe. If you're digging a hole, you have half a dozen levers in front of you, and you only have two hands, so you can only move two levers at once. And so that actually, to do a simple task, such as digging a hole, you have to start going up and moving certain motions, instead of what you would really want is a nice smooth path, which within these control systems we can actually get. And so Unlimited Tomorrow is actually developing these new control systems not only for prosthetics but for multiple other industries: heavy machinery, bomb defusal, mining, security and defense, everything that it has some kind of human control. We see that we could increase the efficiency of that task by really merging man and machine in the correct way, by making something that's intuitive, that's natural, that really focuses on how the human body actually works, and replicating that mechanically, and really transferring that to the user the best way possible. So throughout this, technology is really the core of this, and a great example is when I went into actually building the robotic hand, that was just for fun. I saw a tremendous application which was prosthetics that could really take hold and completely change people's lives. That wasn't something I intended, but also when we started creating this and really started looking at the control systems, we didn't intend to go into these other markets, but technology is so cross-platform that you could design it for one application and it can be used in multiple other applications. And so this was really exciting. This is a tremendous world that we live in today. Now, using these new technologies, there's new technologies coming out all the time. For me, mainly 3D printing is all I use all day, every day. We print so many pieces. We actually have 8 3D printers at our facility that prints 24/7. And having a machine like that can completely change your design philosophy. Imagine now you have a machine that conventionally you would have to use a CNC machine, which is subtractive manufacturing, which in some cases it's incredibly hard to produce complex objects. Now you have a printer that costs pennies to print a small object or a gear that you can see within a few hours, that can print incredibly complex objects out of really amazing materials, such as nylons, flexible materials like rubbers, hard plastics like ABS and PLA, and now even composites like carbon fiber. 3D printing, it moves extremely fast. There's actually this governmental agency with kind of branch within the US called Oak Ridge National Laboratories, which has an incredible additive manufacturing facility. They have printers that can print in metal, that actually fuse titanium together with lasers to actually print full objects. Now that completely changes the whole medical kind of aspect to medical devices as well. A great example is actually a hip implant. You can 3D print a titanium lattice structure, which now instead of actually screwing screws into your bones will actually start growing and fusing to the titanium. And so there's so many technologies. Again, it wasn't made for that application, but that's the goal, is that maybe you actually create something, maybe you have an idea that then opens your eyes up to a tremendous other world of business, of people that you can help that you didn't originally intend for. So that's really what's amazing about today's world. Now, in today's world, you can also collaborate. That's the big thing for what I do is open source, is that you can take an idea, you can elaborate on it, you can make it better and better, and that you get an extremely, almost exponential growth of technology, which for what we're doing is really key in today's world, creating technology to help people. Now, anybody can take their idea to the next level, and that's really what I encourage, is that there's so many ways to really turn your idea into reality. The internet is a tremendous resource, and because of that, there's sites like Kickstarter that will actually allow you to put your idea online and actually have people support you and help actually make a business out of it, or maybe help you reach another goal. Also, open source, making things that are open source actually helps share and maybe get your idea to people easier and better. We didn't have an option to go through FDA approval or go through that whole process such as patenting, just because we didn't have the resources and infrastructure. And so with open source, it costs nothing to make something open source. But with that, you can really target the world with something like this. And so there's a lot of these new business models and these new ways that you can turn your idea to reality. Anybody can. Now, technology moves extremely fast. I'm sure a lot of you probably have a better idea than I do that are older than me about how technology just grows and changes overnight. 3D printing is a great example. Within a few years, it's grown tremendously. It's in almost every school and university, museums now. It's really tremendous how this technology actually grows and can change markets and industries literally overnight. 3D printing is amazing because it's scalable, right? You can print something that microns, such as stem cells and new biomaterials to produce, again, more on the medical side. But you can also print something extremely large, such as components for airplanes, actual molds. There was this really amazing, actually at Oak Ridge, that they were printing a full-size airplane wing out of a 3D printer, which was really bizarre to see actually coming out of a machine. Also, the efficiency, if we can increase the materials, increase the actual time to produce a part, that can change things. We can actually change the whole manufacturing landscape that we know today in today's world. Now we can print hundreds of objects within hours instead of having to go through a very pricey kind of infrastructure change within liquid mold injection machines, making the molds, having a tremendous space and size for that machine. You know, the landscape is definitely changing, and the technology changes with it. Business truly evolves as technology evolves, and that's really key, is that if there wasn't open source technology, I probably wouldn't be speaking in front of you today. It's that there's these models, these new models that evolve with this technology that allow you to really get this to the people who really need it. Now, throughout this whole process, curiosity has really driven me. That's what's kept me going. That's what allows me to ask questions. It's in all of us. It's what makes us wonder why. And curiosity is the key to innovation. It's really up to you to use it as a tool. Take your idea, turn it into reality, and make it your own. Thank you.
Easton Lachappelle, thank you very much. I do believe that there will be some questions. It was a very interesting presentation. So while you're going on with this arm.
Well, people are asking questions. I do also have a quick tech demo.
Questions will come.
So this is actually a telerobotic system. And so you can see that this is completely wireless. This is a control glove. And so as I move my hand, the robotic hand will actually copy my movements with it.
Well done, really. Amazing. Hemen burada önden mikrofonu arkadaşlar getiriyorlar. Evet, buyurun konuşun.
If you don't mind, I will ask in Turkish. Benim 12 yaşında bir kızım var. Gerçekten çok yetenekli. Onu yetiştirirken sizi dinlediğim bazı şeyler dikkatimi çekti ve burada do you have translation or?
He has a daughter, 12 years old, and while educating.
No, I can continue in English if you wish.
O zaman rica edelim yani. Okay.
Thank you.
He changed his mind.
Because some people maybe cannot follow, that's why I think about audience. I have a genius daughter. She's 12 years old. When I listen to you, I also think how can I motivate her about to progress her ability, but at the same time, I was wondering about her inner peace in long term. Because being a successful, being a genius naturally make people lonely. My question is, how do you compensate your inner peace? Thank you. I'm a PhD student businessman in R&D and technology transfer area. Thank you.
Oh, God, great question. For me, that was a great question regarding your daughter. For me, I had tremendous parents. They really encouraged me to make things, to really follow what I like to do, and something that they really encouraged me. They didn't tell me no, which was really valuable. They allowed me to take apart things, to start asking questions, to start talking to people, which was really key. There's so many, even times especially even at school that, I almost just got shut down for a lot of my ideas. But it's how you actually, if you have an idea, having the resources to be able to take that to the next level. For me, that was the internet, but that's not always the case for everybody. And so it's finding the people that also share maybe a similar passion, that really see maybe things in a different light, that can help really excel this learning process or facilitate maybe the next level of that, such as maybe potentially internships, or maybe finding whatever the application or the skill that they want to learn. How do you actually get them into the field? How do you actually get them to live and breathe it? For me, I turned my whole bedroom into a workshop. I had drills, I had 3D printers in there. I was working around the night, actually printing things and assembling it. And for me, that was the design iteration. It was how you actually learn, and I learned by doing and touching. And so it's having that environment that is really constructive to be able to turn your ideas, whatever they are, or your goals, and actually complete them and finish them fully.
Thank you very much, Easton.
Thank you.
That was wonderful to host you today. And I know you have lots of fans. They want to talk to you. And I show you the road to the backstage. So you will meet up with them, okay?
Thank you so much.
Thank you. Bye-bye.